Hello, Matthews Gatos here. Welcome to Chapter 5, Applications of Exponents and Logarithms, and Lesson 1, Solving Equations Involving Exponents. Okay, let's look at an example that you guys have in your books here. The volume of a beach ball is 50,965 centimeters cubed. Determine the radius of the ball. So they start to go through the first couple steps. I just want to go through them with you. So first thing that we do is we state our formula. Volume of a sphere, 4/3 pi r cubed. Okay, next thing that I do is I substitute in the volume, which is the 50,965. So I want to get r cubed by itself, and I'm going to look at two different ways once I've done that. So what I'm going to do is multiply both sides by 3 to get rid of my fraction. So multiply by 3, it's gone there. Multiply by 3 over here. And then what I want to do is divide both sides by 4 pi. Remember, pi is just a number. So divide both sides by 4 pi, it cancels there, and I get r cubed is equal to 3 times 50,965 divided by 4 pi. So at this point here, we have two different students, two different solutions. So Sarah completed the solution by taking the cube root of the equation. So what she said is, okay, the opposite of cubing a number is cube rooting a number. So I'll cube root this side, and to be fair, I also cube root that side. Okay, that's a totally acceptable way of doing it. So I plugged it into my calculator like that. I cube rooted it, and I got 22.999, whole bunch of nines. So I'm going to call it 23, and my units are centimeters. Okay, now Lee, that's my middle name, by the way. I don't know if you guys knew that. My middle name is Lee, and spelled L-E-E. So Lee completed the solution by raising each side of the equation to a specific power. Oh, except Lee is a boy. That's okay. So what power did he use? So we want to get rid of r cubed. So since I'm cubing it, and I know the opposite of cubing is cube rooting, I can also raise to another power to get the cube root. And that power that I can raise to, the reciprocal power, is to the 1/3. So I can raise that to the 1/3 power to get rid of my root. Okay, so cube rooting again, same as raising it to the 1/3. So I'm going to raise it to the reciprocal power. So on this side here, I'll raise it to the 1/3. Let's put that back. My technology is not working with me. Okay. Let's try this again. Pull it over. There we go. And I'm going to be fair, raise the other side to the 1/3 as well. So I can enter that into my calculator as well to figure out what my answer is going to be. So putting that into my calculator, there we are. I get the exact same answer, which I would expect because cube root is the same as raising it to the 1/3. So I also get a radius is equal to 23. So this strategy here is something that we can use. So the following procedure to solve an exponential equation where the exponent is a rational just means fraction. So if I have x to the a over b equal to a number, all I really have to do is raise both sides to the reciprocal power of the exponent after the power is isolated, and then simplify and solve for the variables. So we're going to try this in a bunch of different questions here. So for my first one, I'm solving for x, and x is equal to the 1/2, and it equals to 7. X to the 1/2 equals 7. So I'm going to raise each side to the reciprocal power. And the reason this works is because when I have power to a power, I multiply my powers. So 1 times 2 is 2, over 2 times 1 is 2, 7 squared is 49, and then x to the 2 over 2 is just 1. So that's why it works. So it's just x equaling to 49. Okay, let's try that in part B. Now part B, I can't just raise it to the reciprocal power because I've got this 2 in front here. So remember, you have to isolate your power first. So if I have 2x to the 1/3 equals -1, I'm going to divide both sides by 2 first. So x to the 1/3 equals -1/2. And now I'm going to raise it to the reciprocal power, to both sides to be fair. So 1/3 of 3 is just 1. So it's x to the 1 equals, and then I can put this into my calculator, making sure I use brackets for my base. So putting that into my calculator, brackets around my base before putting it in, bracket -1/2 to the third equals -1/8. This is especially important if our exponent is an even number, because if you don't have brackets around it, it would not give you the correct answer. But let's just put brackets around every base. Okay, here, again, I have to isolate my power by dividing both sides by 5. So x equals -2/3 equals 9. Now we're going to raise that to the reciprocal power, and I get asked a lot, what do you do with the negative? So the reciprocal includes the negative, because I want x to be to the +1 over here. So I'm going to raise this to the reciprocal power and raise this to the reciprocal power. That's important because when I multiply these exponents together, two negatives make a positive. So I get x to the 1 because 2 times 3 is 6, 3 times 2 is 6, so 6 over 6 is just 1. So x to the 1 equals 9 to the -3/2. So I can just put 9 to the -3/2 in my calculator, change it into a little fraction, a little math frac, and I get my answer as 1/27. If you wanted to do that without using the calculator, it would be, if you look at 9 to the -3/2, if you want to do it without the calculator, a negative exponent becomes positive by taking the reciprocal of the base. Now it's positive. And 1/9 will be cubed, and then you're going to take the square root. That will also give you 1/27. Okay, to solve exponential equations, sometimes we need to write them with the same base. So that's what I want to practice now. So an exponential equation is any kind of an equation where the variable is an exponent. So 2 to the exponent of x, x is the variable. 3 to the exponent of x plus 2, x is in the exponent. Okay, so many exponential equations can be solved by writing each side of an equation using the same base. So here's an example. 36 to the exponent of 6 can be written as a base of 6. So notice I used color here just to differentiate. So the base of 36 could be rewritten as 6 squared. And then of course you would multiply your exponents together, so still a base of 6, but 2 times x would be 2x. So I want to practice writing it as the same base, and then you'll see where we're going with that when we solve the equations. So let's say I wanted to write it to the indicated base. So if I want to write 9 as a base of 3, when I really ask you to write it as a base of 3, I'm just asking you to use powers of 3. So 3 to some exponent. So if I want to change it to a base 3, I'm asking you which power of 3 is 9. And you can see right here that 3 squared is the same as 9. So since 9 is the same as 3 squared, 9 to the 2x will be the same as 3 squared to the 2x. And then of course we keep the base and we multiply the exponents together. So 9 to the 2x would be the same as 3 to the 4x. Let's try this one. 125 to a base of 5. So since I'm talking about a base of 5, I need powers of 5. So there are some powers of 5, and you can see that 125 is the same as 5 exponent 3. So 125 to the 2 minus x will be the same as 5 cubed to the 2 minus x. And then I just multiply through 3 times 2 and 3 times x. So it would be 6 minus 3x, 5 to the 6 minus 3x. Okay, let's try this one here. So I'm writing 8 times 16 to the x as a base 2. So since it's a base 2, I need powers of 2. Whoa, really squish it in there. Powers of 2. I'm going to actually make this a little bit smaller so I can fit it in. Okay, so base of 2 means writing it as powers of 2. So looking at 8, I know that 2 to the exponent of 3 is 8, and 2 to the exponent of 4 is 16. So if I have 16 multiplied by 6 to the x, that is going to be 2 cubed for the 8 multiplied by 2 exponent 4 to the x. So this will be 2 cubed multiplied by 2 to the 4x. So 4 times x. And then with laws of exponents, when we multiply exponents with the same base from 10c, we remember that we keep the base the same and add the exponents. So it will just be 2 to the 3 plus 4x. Okay, at this point here, I just want to put in a big plug for the check because you know I'm a big fan of the check. How do I know if I did this right? Is 18 times 16 to the x the same as 2 to the 3 plus 4x? I can use my graphing calculator to check that. Okay, so I put the question into y1, I put my answer that I got into y2, and you can see that y1 equals y2. So since they are equal, I know my answer is correct. So anytime you want to check, if you're not too sure, always use your graphing calculator to help you. And remember, the check always happens in the table. So let's try this one here. This is a little bit weird. So I have 1 over 512 to the 3x, and I want to write that as a base 2. So my 512 is in the denominator. But since I want base 2, again, I'm looking for powers of 2. So powers of 2, I can see all the way down here, 2 to the exponent of 9 is 512. So since I have 1 over 512, I'm going to have 1 over 2 exponent 9, and that will be raised to the 3x. So I'm going to have 1 over 2 to the exponent of 9 times 3x is 27x. And then I can write that because I want it as a power of 2, and right now it's not a power of 2. So I'm going to use my negative exponent law. So to bring this up to be a base of 2, it's going to be a negative exponent. So I just want to review with you guys negative exponents. So if you have, for example, let me just go back to negative exponents. If you have x to the negative n, that's the same as taking the reciprocal of the base, and now the exponent is positive. The same thing is true going the other way around. If you have a fraction and you want to go back to a whole number base, you can do that by taking the exponent and making it negative. So it works both ways. And again, if you're ever unsure, you can always check that in your calculator. Okay, let's try this one here. 16 over 81 to the x plus 5 to the base of 2 over 3. So I want powers of 2/3. So powers of 2/3. So I put that into my calculator. Let me make this a little bit smaller so it can fit better. There we are. So I write it as powers of 2/3. So y equals 2/3 to the power of x. I want it to be 16 over 81. So I can see that's to the power of 4. So 16 over 81 is the same as 2/3 to the exponent of 4. So 16 over 81 to the x plus 5 will be the same as 2/3 to the exponent of 4 to the x plus 5. So I'm going to keep my base here, and I'm going to multiply my exponents, 4x plus 20. Okay, let's look now why we're doing this. We want to solve exponential equations with a common base. So here's what we're going to do. We're going to write each side of the equation in the same base. Now the question's not going to tell you which base to use. So my advice to you is always go to the smaller base and see if that works. And if that doesn't work, go smaller than the smaller base. So write each side of the equation with the same base. If necessary, use exponent laws so that each side of the equation contains only one base. That's really important. So once you have only one base, you're going to make the exponents equal on each side of the equation and determine the value of the variable. So basically what it's saying is that if you have b to the exponent of a the same as b to the exponent of c, see they're the same base here, then a must equal c. So if the base is the same and the left side equals the right side, then the exponents must be the same as well. So let's try this one. So I want to solve this equation. So the biggest trick is putting the bases as the same. And you can see the bases here are the same. They're both a 5. So what we are going to do is we're just going to make like a DJ. Well, what do I mean make like a DJ? Since the bases are the same, I am going to drop the base. So by dropping the base, I can say since the bases are the same, the exponent must be the same as well. So little Gato's humor there for you. Drop the base, subtract 3 from both sides, and I end up with 2x equals 4. Divide both sides by 2, and I get an answer of x equal to 2. So that's why we're reviewing all of those writing as a common base parts. Okay, so let's look at a question here. Oh, I lied. Before we go on to the next question, always a good idea to check. Now you can actually check by replacing x with 2, because that's what I got as my answer. Or you can always do it the way I do in the calculator as well. You can do y1, y2, start the table at 2. Here's just another way that you can do it. If I replace x with 2, I can see if it's right. So 5 to the 2 times 2 plus 3 is the same as 5 to the 7, so I know that I am correct. Okay, let's try this one here. 7 to the x minus 2 equals to 343. So I want to write these as the same base. So again, I suggested always looking to the smaller base. So can I write 343 as a power of 7? So I go into my calculator and I look at my powers of 7, and I can see that 7 cubed is the same as 343. So yes, I can. So 7 to the x minus 2 will be the same as 7 cubed. And then I make like a DJ and I drop the base. So I have x minus 2 equals 3, add 2 to both sides, and I get that x is equal to 5. And then you can see I do a quick check by replacing the x with a 5. 5 take away 2 is the same as 7 to the 5 take away 2 is the same as 343. So I know that I have answered my question correctly. Okay, let's try another one. So this one here, 3 to the 5x minus 1 and 81 to the 3x, always go to the smaller base. Let's go to 3 and see, can we write 81 as a power of 3? And yes, I see right there I can. So I'm going to have 3 to the 5x minus 1 is the same as 81, which is 3 exponent 4 to the 3x. So this will be 3 to the 5x minus 1 equals 3 to the 12x. So now that the bases are the same, I make like a DJ and drop my base. And then I just solve for x. So I will, let's see, I'm going to subtract 5x from both sides. And then divide both sides by 7. And I get that x is equal to negative 1 over 7. So again, you can always check that by replacing x with negative 1 over 7, which you can see I did here. 3 to the 5x minus 1, 81 to the 3x, x is negative 1/7. I get the same answer on both sides, so I know that I am correct. Okay, let's try another one. So 3 to the x equals 27 times the root of 3. So I really need to tidy this up a little bit, okay? Because I only want one base on each side. Remembering, of course, that 3 is the same as 3 to the 1/2. So I'm going to have 3 to the x is equal to 27 times the square root of 3 is 3 to the 1/2. Now I can't just multiply 27 and 3 beside each other because this is not a 3, it's a 3 to the exponent of 1/2, which is the square root of 3. So I need to simplify using a common base. So again, I go to my smaller base, which is 3, and I want to write everything as a power of 3. So 3 to the x, already a power of 3. 27 I can see is the same as 3 cubed, and that will be multiplied by the square root of 3, 3 to the 1/2. So laws of exponents, keep my base the same, add my exponents. So 3 plus 1/2 is 3.5. I'll just write it as 3.5. 3.5 or 7 over 2, whichever you prefer. Now that the bases are the same on both, I drop my base, and x is equal to 3.5 or 7/2. So I'm going to put that into my calculator in my original equation, 3 to the x, you can see 3 to the x here, and then 27 root 3, and you can see that they match, so I know that my answer is okay. So 10C coming back, being very useful here. Okay, let's look at number 4. So a bacterium, that's just the plural of bacteria, triples every 6 days. The number of bacteria, N, present after X days is given by the formula N equals 3 to the X over 6. After how many days are there 243 bacteria? So 243 is an N value. Okay, so that 243 is the same as the N value. So I can rewrite this as 243 equals 3 to the X over 6. Okay, so the bacteria is replaced with N because N was the number of bacteria. So to solve this, again, I want to write it as a common base. And I always go to my smaller exponent, which is 3, and I check to see, is 243 a power of 3? You can see there it is. So 3 to the exponent of 5 is the same as 3 to the x over 6. So I have power equal to a power, same base on both sides. I drop the base, and I get 5 equals x over 6. So since I've divided x by 6, I'll multiply x by 6 and be fair to do it to the same thing to the both sides. And I get that x is equal to 30. So 30 days, it would take 30 days for there to be 243 bacteria. Okay. Last question here, I believe. Last question, yes. So consider the exponential equation 27 to the x minus 2 equals to 1 over 81 to the x plus 3. Solve the equation using a graphical method. Well, the way that we solve things graphically is we do y1, y2 intersect. So I did that over here, y1, y2 intersect. And you can see I have my intersection here. So my solution, not exact, is that it's about negative 0.9. Now remember, this has come up a couple of times before, and I call that 0 in disguise. So it's just a number in scientific notation. So this is like saying 8.1356 times 10 to the exponent of negative 5. So that would be 0.000081356. Essentially, we'll just call that 0 if that ever happens to you. So I can solve it graphically and see that the solution is about 0.9. But I want to look at how I can solve that algebraically. Okay, so if I want to solve it algebraically, I want to convert each side to a common base. So 27 is not a power of 81. So remember how I said you go to the smaller base? That sometimes works. So since this case it doesn't work, I need to go smaller than 27 and find a base that would be common to 27 and 8. So I know that 27 and 8 have a factor of 3 in common. So I'm going to go down to my powers of 3 and I'm going to look. 27 is there, and so is 81. So I can write those as a common base of 3. So I'm going to write 27 as 3 cubed, and 27 is to the x minus 2. 81 is 3 to the exponent of 4. So 3 to the exponent of 4 will be raised to the x plus 3. Okay, so I have 3 to the 3x minus 3 times 2 is 6. Equals 1 over 3 to the 4x plus 12. Now I need the same base on both sides, and I don't have a base of 3 on both sides. This is 1 over 3 to the 4x plus 12. So I'm going to keep my base 3 here, and then to change from a 1 over to a base of 3, I just make my exponent the opposite sign by multiplying it by negative 1 using that negative exponent law. So to bring it up, the 4x becomes negative and the 12 also becomes negative. So now that they're the same on both sides, I drop my base and I get 3x minus 6 equals negative 4x minus 12. And then I add 4x to both sides, getting rid of that. So I get 7x. And to get x on one side now, to get the number on the other side, I add 6 to both sides, and then I divide both sides by 7. So my answer should be x equals negative 6 over 7. I wonder if that's the same answer as what I got over here, about negative 0.9. Let's check. So I got negative 6 over 7. So let's just go into my calculator and do negative 6 divided by 7 and see if I have a match. And I do. That's what I got graphically. So I know that I've done it right. Okay? So that answer there matches negative 6 over 7. So you've seen graphical and algebraic way of doing it. Okay, to summarize our lesson, if we have exponential functions or equations that have rational exponents, raise both sides to the reciprocal power. Exponential equations can be solved by writing both sides with the same base, and then you drop the base and solve. And you can always check your answer on the graphing calculator, and I do recommend you do so. So I thought Professor Snape would be very appropriate here. Pay attention. I shall only drop the base only once. So you guys can go to your practice questions, and I hope this video helped. I will see you for the next one in lesson 2.